In this section, we will talk about how to load data into a Microsoft Fabric data warehouse. In this section, we will talk about strategies for loading data into a data warehouse in Microsoft Fabric. We will focus on loading data into a warehouse using a data pipeline, T-SQL, and Dataflow Gen 2. The ETL, or extract, transform, and load process, is a fundamental aspect of data warehousing, enabling the integration of data from various sources into a centralized repository for analysis and reporting. The Microsoft Fabric data warehouse, the ETL process is streamlined and efficient, leveraging powerful tools and integrations. The E, or extract, requires identifying and connecting to various data sources such as databases, flat files, API, and other cloud services. Consider using tools like pipelines or Dataflow Gen 2 to extract data from these sources. The T, or transform, is where we can clean and extract data to remove inconsistencies, deduplicates, and errors as we transform the data into a suitable format for analysis. We're scrubbing or shaping the data here. This is where most of the heavy lifting occurs in the ETL process. We can use tools like pipelines, Dataflow Gen 2, SQL scripts, all of them to help us perform these transformations. The L, or load, is where we load the transformed data into the fact or dimension tables in the Microsoft Fabric data warehouse. We integrate data into the warehouse schema. We ensure we have relationships and that we have our constraints maintained. We want to use pipelines or SQL scripts to load data into the warehouse. Post-optimization tasks are essential to ensure that your data warehouse performs efficiently and effectively after the initial optimization efforts. These tasks help maintain performance, improve data quality, and ensure the system remains scalable and secure. Regularly monitor the performance of the data warehouse using tools like Azure Monitor and Azure Log Analytics. Also, track key performance metrics such as query response times, resource utilization, and data load times. Consider setting up alerts for performance, degradation, or anomalies to proactively address issues. Rebuild indexes and keep indexes up to date. Profile your data to analyze data quality and identify issues. Continuously cleanse data to remove duplicates, correct errors, and handle missing values. Implement data archiving, strategies to move older, less frequently accessed data to cheaper storage solutions. Remember also to schedule these regular maintenance and optimization tasks. Staging data in Microsoft Fabric Data Warehouse is a crucial step in the ETL process. It involves temporarily storing and transforming data before it's loaded into the final data warehouse tables. This approach simplifies load operations and ensures data quality and consistency. Staging areas provide a temporary storage location for raw data extracted from various sources. Data in the staging area can be cleaned, transformed, and validated before being loaded into the final data warehouse tables. By staging data, you can streamline the loading process, making it more efficient and manageable. Staging allows for thorough data cleansing and validation, ensuring that only high-quality data is loaded into the data warehouse. Transforming data in the staging area reduces the complexity and transformation during the load phase, improving overall performance. Staging provides an opportunity to identify and handle errors in the data before it reaches the final warehouse tables. Create a separate schema or database for staging tables to keep them distinct from the final warehouse tables. Implement transformation logic within the staging area to clean aggregate and enrich data, extract raw data from various sources, and load it into staging tables. Apply transformations to the data in the staging area, including data cleansing, normalization, and enrichment. And then load the transformed data from the staging table into the final data warehouse table. And now it's ready for analytics and reporting. There are different data load types that we need to discuss: the full and the initial load, and the incremental load. The full or initial load is the process of pre-populating the data warehouse for the first time. All the tables are truncated and reloaded, and the old data is lost. This load can take longer to complete due to the amount of data being handled. It's also easier to implement as there's no history being preserved. This method is typically used when setting up a new data warehouse or when a complete refresh of the data is required. The incremental load is the process of updating the data warehouse with the changes since the last update. The history is preserved and the tables are updated with new information. Compared to the initial load, the incremental load takes less time and is more complex. This method is commonly used for regular updates to the data warehouse, such as updating it every day or every hour. Lastly, it requires mechanisms to track changes in the source data since the last load. Usually, the full or initial load is done first, just one time, to add initial data to the destination table, and then the incremental load is going to be used going forward to add more data and changes to the destination table as they happen at the source. Now let's talk about two-dimension keys, a surrogate key and an alternate key. Surrogate keys only exist in the data warehouse, and they're rarely used they are used to uniquely identify each row in a dimension table, essentially. It's a primary key for the dimension table, and it's usually implemented as a simple, unique integer value. Alternate keys identify a specific instance of a dimension entity, such as a customer, and are often inherited from the source operational system, the business key for the entity, or they're based on a natural key that uniquely identifies an entity, such as an email address for a customer. The important point is that the dimension table might need to contain multiple records for a specific entity instance to represent its attributes at different points in time. For example, in the slide, there's a customer named Navin Jones, who at some point moved from Seattle to New York. The table contains 2 records for this customer, so that when aggregating sales by city, sales to the customer are counted for the city of residence at the time of the sale. It's the same customer, so the alternate key is the same for both records. But the surrogate key enables us to maintain a separate record for each city where they lived. Note that the example on the slide is simplistic. Although not shown here, it's common for slowly changing dimensions like this to include columns to indicate the effective dates for each record and a flag to indicate which record for a given alternative key represents the current version of the entity. Creating a table using T-SQL in Microsoft Fabric Data Warehouse involves several steps that can be done connecting to the Fabric Data Warehouse using the SQL Server Management Studio, SSMS, or using the Microsoft Portal. To connect to the data warehouse from SSMS, you will need the SQL connection string. To copy the SQL connection string, go to the workspace where the data warehouse is stored and hover over the data warehouse, and then click the 3 dots and select Copy SQL Connection String. Use the SQL connection string in the SSMS or the SQL Server Management Studio when you connect to a database as the name of the server. To create a table using the Fabric portal, find the workspace that contains the data warehouse that you'd like to create the table in and select it. Once in the data warehouse, you can select SQL templates to create a new table in the ribbon up top, or click New SQL Query and type your Create a Table T-SQL syntax, or select New Visual Query to start. In our example here, we're creating a table called DIM Product that has 4 fields: product ID, product name, category ID, and price. Notice that each of these fields has a data type associated to it: integer, non-varchar, or decimal, which represents the type of data to be stored in it. Note too that the product ID field will be the primary key. Slowly changing dimensions, or SCD, are a concept in data warehousing used to manage and track changes in dimension data over time. In a Microsoft Fabric data warehouse, implementing a slowly changing dimension involves handling changes to dimension tables in a way that preserves historical accuracy and allows for effective analysis. Slowly changing dimensions change over time, but a slow pace and unpredictably. For example, a customer's address in a retail business. When a customer moves, their address changes. If you overwrite the old address with the new one, you lose the history. But if you want to analyze historical sales data, you might need to know where the customer lived at the time of each sale. This is where slowly changing dimensions come into play. There are several types of slowly changing dimensions, each with its own method for managing changes. The most frequently used are Type 1 and Type 2. Type 1 slowly changing dimensions overwrites existing data and doesn't keep a history, while Type 2 slowly changing dimensions adds new records for changes and keeps a full history for a given natural key. In our example here, we see that our source online transaction processing table is being queried for records updated or inserted since the last successful load. Notice we're looking for a modified date that is greater than 10/1/21 and less than our current date. The records that meet this criteria are loaded into the DIM product table, which is our Data Warehouse Online Analytical Processing Table, or OLTP table. We're using slowly changing dimension Type 2, so we're making the new version that with the updated name as the new active record, and the old version uses bicycle as inactive. Notice we're looking for a modified date that is greater than 10/1/21 and less than our current date. The records that meet this criteria are loaded into the DIM product table, which is our Data Warehouse Online Analytical Processing Table, or OLTP table. We're using slowly changing dimension Type 2, so we're marking the new version with the updated name as the new active record and the old version using bicycle as the inactive record. In Type 2 slowly changing dimensions, when a new version of the same element is brought into the data warehouse, the old version is considered expired, and the new one becomes active. The provided SQL syntax is used to implement a slowly changing dimension, or Type 2, for the DIM products table. This type of slowly changing dimension preserves historical data by creating new records for changes rather than overriding existing data. In our example, the if exists clause query checks if there's at least one row where the source key matches the @product ID and is active is true. If an active record exists, the begin block executes the update statement This updates the existing active record by setting validate to the current date and marking the record as inactive with the isActive equal to false. This effectively closes the validity period of the current record. If no active record exists, the else block executes the insert statement. This inserts a new row into the DIM products table with the provided product details. This new row represents the current state of the product, and it's marked as active. This SQL syntax ensures that changes to product data are tracked over time by creating new records for each change while preserving historical data. The DIM products table will have multiple rows for each product, each representing a different period of validity. Remember that the mechanism for detecting changes in source systems is crucial for determining when records are created, inserted, updated, or deleted, or a CRUD statement. Various methods such as change data capture, triggers, timestamps, hashing, and log-based change detection can be used. Tools like SQL Server, CDC, pipelines, and more can be used. The key challenge in loading fact tables is the need to look up the correct surrogate keys for each row. Typically, the stage data will include the alternate business or natural key, but you need to use the surrogate key in the fact table so that each row is related to the correct instance of each dimension for the time at which the fact occurred. In the code example on the slide, an assumption is being made that the fact records being loaded all relate to the latest version of all dimensions, and that each dimension table uses an incrementing surrogate key so that the code looks up the highest surrogate key value for each alternate key. In some cases, the logic to find the right surrogate key may be more complex. For example, in this case, you might need to use the order date to find the appropriate DIM customer record for the customer's alternate key on the date the order was placed. Remember, too, that the need to look up the dimension surrogate key, which means that in most data warehouse loading processes, dimension tables must be loaded before the fact table. Note that the provided SQL statement is used to insert data into the fact sales table from the stage sales staging table. It involves mapping foreign keys from dimension tables, DIM date, DIM customer, DIM product, DIM store, to the corresponding keys in the fact sales table. Loading data with a Microsoft Fabric pipeline involves several steps, including orchestrating activities, copying data, scheduling and using parameters, and deleting data. Pipelines offer many different activities for orchestrating data movement. However, the most common activity for loading data into the warehouse is copy data. Orchestrating activities in Microsoft Fabric involves coordinating and managing the execution of various tasks within the data pipeline. This ensures that tasks are executed in the correct order and the dependencies are managed. Once you create the pipeline, you can add activities to the pipeline, such as data movement, data transformation, and control flow activities. The copy data activity is used to move data from a source to a destination. This can involve copying data from various sources such as databases, files, or cloud storage to your data warehouse. Scheduling allows you to automate the execution of your pipeline at specified times or intervals. Parameters are used to make your pipelines more flexible and reusable by allowing you to pass different values during execution. Deleting data involves removing old or unnecessary data from your data warehouse to maintain efficiency and manage storage. Configuring a copy data activity is wizard-driven in Microsoft Fabric and involves several steps to ensure data is accurately and efficiently transferred from a source to a destination. The first step is to choose the data source. This is where you select the data source from which you want to copy data, like SQL Server, Azure Blob Storage, etc. Next, you connect to a data source. Select Preview and choose the data. This can be done from tables or views, or you can customize your selection by providing your own query. Next, choose Data Destination, which can be SQL Server, Azure Data Lake, etc. Next, connect to Data Destination. Select and map columns from source to destination. You can load to a new or existing table. Lastly, configure other settings like staging and default values. I think you'll find the Copy Data Activity Wizard very easy to use. Finally, you might be asking, when would I use it? Consider using the Copy Data activity for data migration. When you're moving data from maybe on-premise SQL to Azure SQL Database, or use it for data integration to integrate the data from multiple sources into a single data warehouse, or use it for data backup to copy data to a backup storage location for disaster recovery, or even for data transformation to transform data during the copy process using mapping and transformation rules. Now let's talk about loading data with T-SQL. One way to load data using T-SQL into the data warehouse is to use the copy statement. This is the main method for importing data into a warehouse. It facilitates efficient data ingestion from an external Azure storage account. It offers flexibility, allowing you to specify the format of the source file, designate a location for storing rows that are rejected during the import process, and to skip header rows, among other configurable options. The option to store rejected rows separately is useful for data cleaning and quality control. It allows you to easily identify and investigate any issues with the data that weren't successfully imported. The option to use a different storage account for the error file location, rejected row location, allows for better error handling and debugging. It makes it easier to isolate and investigate any issues that occur during the data loading process. Error file only applies to CSV. The ability to specify wildcards and multiple files in the storage location path allows the copy statement to handle bulk data loading efficiently. This is useful when dealing with large data sets distributed across multiple files. Note that you can load a CSV file or a Parquet file. In our example, we're loading from a CSV file. We're copying into my table from two locations separated by a comma. They are both using my blob container from the Azure Blob Storage account, my account. We can also load a Parquet file using the My Blob container in the Azure Blob Storage account, my account, as a source too. Note that both options require shared access signatures, with our SAS token to connect to our Azure storage account, and the file type needs to be set to either CSV or Parquet. You can load data from various items in a workspace, such as other warehouses and lakehouses. In a scenario where an analyst needs data from both a warehouse and lakehouse, they can use this feature to combine the data. They can then load this combined data into a warehouse for analysis. This feature is useful when data is distributed across many assets in a workspace. All the warehouses that share the same workspace are integrated into the same logical SQL Server. If you use SQL client tools, such as the SQL Server Management Studio, you can easily perform a cross-database query like any other SQL Server instance. If you're using the Object Explorer from the workspace to query your warehouses, you need to add them explicitly. The warehouses added will also be visible from the Visual Query Editor. In the example shown here, we can use the create table as select statement to create a new table called combined data in the analysis warehouse based on combining the sales data table from the sales warehouse being joined with the social data table from the social lakehouse using matching product IDs between the two tables. Likewise, we can use the insert select statement to add records into an existing table called combined data in the analysis warehouse. Whether we select the create table as select statement or the insert select statement depends on whether the target table needs to be created or already exists. You can also ingest and transform data with Dataflow Gen 2, which is Power Query Online Editor. To ingest data into Dataflow Gen 2, we will first need to connect to the data source. Dataflow Gen 2 supports 150 data source connectors to data sources including Lakehouse, Warehouse, Azure SQL Database, Azure Data Explorer, and Azure Synapse Analytics, and more. Once the data is imported, you can transform your data by authoring your data flow, by cleaning, reshaping, removing, and creating columns, and etc. There are over 300 plus transformations to choose from. Once connected to the data source, you can choose to either append new data to existing data sets or replace the existing data entirely. This decision depends on the nature of the data and the requirements of the analyst. After processing the data, you need to specify where the transformed data will be stored. The destinations are the same as the data sources identified earlier. With the Add Data Destination feature, you can separate your ETL logic and destination storage. This separation can lead to cleaner, more manageable code and can make it easier to modify either the ETL process or the storage configuration without affecting the other. Consider also transforming your data with Copilot. Copilot can be a valuable tool for assisting with data flow transformations. The first step is to activate Copilot within your data flow. To activate Copilot, you will need a Fabric SKU or a premium subscription assigned capacity to the workspace where the data flow resides. Once that's done, you can then provide specific instructions on the transformation you want to perform in Copilot. For instance, you might input the following prompt or command. Transform the gender column, if male, 0, if female, 1. Then convert it to an integer. Press enter and then watch Copilot make the changes. You could also have Copilot give you tips and best practices on creating data flows. It can also look for issues and errors and help you to fix current data flows. You can even have it summarize or explain a current data flow to you and more. Now let's see how to load data into a data warehouse in Microsoft Fabric. Now let's move into how to load data into a warehouse using T-SQL. Now, as you can see, I already have my Fabric workspace created. So what I'm going to do is I'm going to actually create a Lakehouse right now, and we're going to use it as the source for our data warehouse as we load data from the Lakehouse to the data warehouse. So I'm going to go ahead and find that Lakehouse, and I'm going to give my Lakehouse a name. And we'll keep that there. That looks good. And then what I'm going to do with this Lakehouse is I'm going to go ahead and upload some data to it. And we used this file earlier
This is the path for it. You can download it, and once it's downloaded, it will create a sales.csv file that we're going to be using as our source. So I'm going to upload it right here into our Lakehouse. We can see our SQL Analytics endpoint was created. I'm going to go ahead and pull that file in, and there it is right there. And let me go ahead and upload that. Okay, so we should have the file. We can check it. It should be right here under files. There it is. And it's actually a very large file, as you might see. There's a lot of records in here, a ton of records we have available in here. Maybe 31,000 plus records there. So a lot of records to work with. Now, what I'm also going to do is I want to use this CSV. So we've ingested this CSV file with 31,000 plus records. And what I want to do is I want to turn this CSV file into a table. And I'm going to use that table as our source. So I'm going to create a table from this, but I'm going to call it a different name than sales here, because it's essentially going to be our staging table. So I'm going to call it staging underscore sales. And that will be the name of that table that I want it to create. Now, remember what it will do here is it's going to create essentially a delta table for us. And we'll eventually see it here. It's still loading it. And then we'll use that as our source for loading our data warehouse. So the Lakehouse and the warehouse can work in tandem together. And we've ingested data into files, raw data into files, and we've made a table out of it here, our staging table. We can get a little preview out of that if you'd like. It should look very similar to the CSV, only it's organized now into columns and rows. Okay, so this is going to be our source. And then what we're going to do is make our warehouse. So I'm going to come back to our workspace, and you can see some of the objects that were created from that Lakehouse you're familiar with. Now we're going to make our warehouse, and our warehouse is going to ingest data from that staging delta table in the Lakehouse. So I'm going to call our warehouse this name right here. Excuse me. And let me go ahead and pull that in. So there we go. We have our warehouse created. Now the warehouse doesn't have a whole lot in it right now. So we're going to need to load some data. I want you to see the schemas that are there right now. Doesn't look like we can really see anything. It'll take it a moment, but we should have some default schemas there. And what we're going to do is we're going to create some fact table, dimensions, and a view. And we're going to do it really through our statement here. So we're going to put our objects in a separate schema called sales. And if it doesn't already exist, we are going to be able to create here a table. So we're going to create a fact sales table, a dim customer table. We're also going to go in and alter that dim customer table, create some constraints on it. And we're going to make another table called dim item. So we'll go ahead and run that. And that's going to create that schema called sales. And then we're going to put our new tables under that sales schema. So you can see the sales schema right here. And if I go into tables, we might be able to see those tables. It'll just take a moment to refresh itself. There we go. So you see the fact sales table, you see our dim customer and our dim item. Okay, so those are all there, ready to go. And now what I'm going to do is I'm going to create a view. This view is a very important view because this view we're going to use to extract data from our warehouse. So we're going to call the view staging sales. It's going to be under the sales schema, and it's going to pull in from our Lakehouse. So the tricky part here is remembering, what did we call that Lakehouse? And you can kind of see the name there off to the side. I'm just going to go ahead, and I didn't copy paste it ahead of time, so I'm just going to type it in here. So it's our Lakehouse here, or sorry, we want to pull up the Lakehouse, and I can see its name from right here. So that should be it. So we have it there. So we're going to select from that Lakehouse, and we're going to select from its staging sales delta table. Remember, we ingested the sales CSV into files, and then we made a table out of it called staging sales, and we're going to use it right here. So let me go ahead and run this, and that will create the view that brings it together. And then you can see the view from right here. This is the view right here. So that little view gives us a little view. So we can see that it's actually working. It's pulling in the data from the staging sales delta table in our Lakehouse. So that looks good so far. Now what we want to do is we want to use that view ultimately to pull in our data. So I'm going to make another query here. And this query is actually going to create a stored procedure. You can see it up at the top. It's called sales.load data from staging, and it has a parameter which it requires the order year in an integer format. And so that stored procedure is going to insert into dim customer and dim item and the fact sales table based on the information in that staging table. So we're going to go ahead and run this, and then we'll see our stored procedure eventually right in here. There it is right there. There's that stored procedure that we just created. Okay, and it's all off that sales schema, which makes it really handy to be able to find. Now what we're going to do is we're going to go ahead and load some data with a stored procedure. So that stored procedure we just created, we are going to now execute it. And we're going to ask it, you may remember that the sales CSV file actually has data from 2019, 2020, and 2021. We only want to pull in the 2021 data. Now, we could adjust this and we could ask for different years, but it only has one parameter. It's the order year. So it looks like it's pulling it in now for us, and it pulled in a ton of records. How are we going to see those records? See them a lot of ways, but we're going to do it through a query. So I'm going to go ahead and run another SQL query out here. And let's take a look at that information. So what we're going to do is we're going to extract information from fact sales by doing a join here also with customer, matching customer IDs. But we're specifically asking for year 2021 because the information that it currently has is 2021. That's what we imported in. And we can see some of that information here. Now I'm going to run another query. And let me open, actually I might just do it right here. Let me go a little lower, and I'll add this query. This query is doing a join between fact sales and the dim item table. And you can see there, again, we're trying to test it to see if we got 2021 information loaded. So we've tested both of our dimension tables. So that looks good there. Now we're going to do another query, and this could be a really good query because this is a query that we might use. Let me actually, it's a fairly long, let me open up a new query window there. This is a big one here, but this is where we want to get some critical information, and it's using fact sales, the customer table, and the item table, and you can kind of see that right in the center. And when we run this, you're going to see that it's going to give us some really good information. And it runs pretty fast too. So it's showing us essentially the top customer for each of our categories: bike, helmet, and gloves, and then who that customer is by name, and then their total sales. So that looks really good, and that could be very helpful for us to make certain that we target some information towards them, marketing information, since they are our top customer in those categories. Okay, so that looks good. Thank you so much for joining in this session, and I look forward to seeing you in our next session.
It's time for our knowledge check. Question 1. What are the 4 data ingestion options available in Microsoft Fabric for loading data into a data warehouse? Answer: copy T-SQL, data pipelines, data flows, and cross-warehouse. Question 2. What are the supported data sources and file formats for the copy T-SQL statement in a warehouse? Answer: Azure Data Lake Storage Gen 2 and Azure Blob Storage with Parquet and CSV file formats. Question 3. What is the recommended minimum file size when working with external data on files in Microsoft Fabric? Answer: at least 4 megabytes. We covered a lot in this module. We talked about the ETL, or the extract, transform, and load process, along with post-load optimization tips. We also talked about staging our data and some of the different data load types like full or initial load and the incremental load, and when to use them. We defined 2 types of dimension keys, the surrogate key and the alternate key, and their use cases. We also talked about how to create tables with T-SQL using both the SQL Server Management Studio and the Microsoft Fabric Service Portal. We also took a look at slowly changing dimensions and how to load fact tables with the insert statement, and we used pipelines to load data into the data warehouse. We looked at the copy data wizard available in pipelines as a way to load data, and saw many other ways to load data with T-SQL's copy into statement, using the 3-part name in the create table as select and insert select statements. We noted that Dataflow Gen 2 could be used to both load and transform data. And lastly, we saw we could transform data with Copilot too. For more information on how to load data into Microsoft Data Warehouse, please see the link here.